So our target 1.7 day 2 says I can apply the volume formulas to more complex situations. Okay, so today we're going to still use those volume formulas, but again, we're going to be doing some more things with them and some more interesting things with them. So the first thing we're going to look at is Cavalieri's principle. The name isn't super important, like I'm not going to test you on like what is Cavalieri's principle, but you should know when you see a problem that uses it, right, you want to be able to use it correctly. So what Cavalieri's principle says is if two or more figures have the same height and the same area at every cross section, then they have the same volume. So for example, this cylinder, right, this one is straight up and down. This one is like pushed over to the side, it's crooked, like the Leaning Tower of Pisa. Okay, and what Cavalieri's principle says is since these have the same radius and the same height, if I were to measure straight down, okay, so I'm measuring height straight up and down, not like I wouldn't measure it like slanted at all. Okay, so since they have the same radius and the same height, these are going to have the same volume. Same thing with like a pyramid, right? I could slant my pyramid, but as long as they have the same length and width and the same height, they're going to have the same volume. So why do we care about that, right? We care because if I have a shape like this, I know I can just find my volume regularly, just like we did yesterday. Okay, so basically Cavalieri's principle says if your shape is slanted, don't do anything differently. It's still going to have the same volume. So let's look at some examples. So we have this slanted shape here, okay, but this is still a prism, right? So I can see that this is still kind of a prism. It's slanted, but our volume formula my volume formula is still going to be the same. I'm still going to use length, width, and height. So my length here, I'm going to say is 2.5. My width right here is 4.9. And my height is this piece over here, right? It's going straight down from like the slant. Okay, and that is 2.2. So just like we did yesterday, right, I just have to multiply these out. For sake of time, I'm not going to pull up the calculator, but we get 28.95. My unit is meters cubed. So again, just because it's slanted doesn't mean anything, right? As long as I have this height here, right, that straight up and down height, I can still find my volume. Same thing here with example B, right? This is a cone, So our volume of a cone, right, it comes to a point, so we always have the 1/3, and then it's a circle, right? So that's pi r squared. Right, kind of tricks to help us remember which volume formula goes with which shape. So 1/3 pi. What is our radius? Our radius is down here, right? It already is half of my circle, so I don't have to cut it in half. 6 squared. And my height, right, is this piece going straight down here, and that's 12. Again, I'm going to type 1/3, 6 squared, and 12 into my calculator. And again, for sake of time, right, I'll just let you know that when we type that in the calculator, we get 144 pi yards cubed. Okay. So yeah, Cavalieri's principle is basically telling us that we can do exactly what we did yesterday. So that's pretty nice. Okay, let's look at example 2. Example 2 says, solve for x, given the volume of the square pyramid is 1,575 inches cubed. Okay. So now here, we're kind of going backwards again. Here, I know the volume, but I don't know, right, x is like the height. Okay. We're still going to use our formula. So now we're applying the formula in a different way. So this is a pyramid, so let's start with the formula of a pyramid. So volume equals 1/3 times length times width times height. And now I'm going to figure out, what do I know? Well, I know the length. I know the width. I don't know the height, right? My height is just this x. This isn't enough, though, to solve for x, but there is one other piece of information I know. I know that my volume is 1,575 inches cubed. So what I'm going to do is I'm going to put that 1,575 here. Right. So now this is an equation I'm solving. The first thing I'm going to do is simplify both my sides. So 1575, that can't simplify anymore. My right side, however, I can multiply 1/3 times 15 times 15. And when I multiply 1/3 times 15 times 15, I believe I get 75. And then I still have this x. Now this is just an equation I'm solving. I'm solving for x, right? X has the 75 with it, so I'm going to divide both sides by 75. 1,575 divided by 75, feel free to type it in a calculator, is 21. And we divide by 75 because those cancel, so I'm left with x. I do want units. This is in inches. It says inches cubed, so this is 21 inches. Your height is just a single length. There's no squared, no cubed on your inches, right? It's just your one dimension. So it is just 21 inches. Okay, let's look at example 3. Very similar. So here I have a picture of a cylinder, but it might just give it to you in words. So we're going to fill in our picture a little bit. So we're going to solve for the radius of a cylinder given the height is 12 centimeters and the volume is 768 pi centimeters cubed. So again, I know it's a cylinder, so we can always make a picture, right? There's our cylinder. We're solving for the radius. So I'm going to put my radius in, and that's going to be x. We're given that the height is 12 centimeters. So my height would be here. It's going to be 12. Okay, so sometimes it will tell you your information in words instead of in a picture. You'll have to just kind of fill it in. So now I'm finding the volume of this cylinder. So I'm going to start with the volume formula for a cylinder. Well, volume equals pi r squared times height. Again, I'm going to fill in what I know. Do I know the volume? Yes, the volume is 768 pi centimeters cubed. So I'll just put 768 pi. We don't necessarily need the units, right, when we're doing the math, so you can kind of leave them off. Equals pi. Do we know our radius? No, our radius is just x. Squared. Do I know my height? Yes, right? We decided our height was 12. So I plugged everything in. And now I want to make sure both my sides are simplified. So 768 pi, that can't really do anything else. On the other side, it's just kind of rearranging things. We always put like numbers first. So I have 12, we still have a pi, and our variables always kind of go last. So I would write that as 12 pi x squared. Your order is not super important, but writing it like this is probably the easiest way to like see what you're solving for. So now we're solving for our x squared here, right? So we're solving for x actually. We have our x there. We need to get rid of our 12 pi. So I'll divide both sides by 12 pi. And what's nice about that is there's a pi here and a pi here. The pi's cancel out. So all I'm really doing is 768 divided by 12. And 768 divided by 12 is 64. Right? And we divide by 12 pi because we have a 12 pi here and a 12 pi here. Right? So I'm left with that x squared. So I'm still solving for x. I'm not quite done yet because I want x equals, not x squared equals. So I need to do the opposite of squaring. The opposite of squaring something is taking the square root. So I'm going to take the square roots of 64. And I'm going to take the square roots of x squared. Why do I do that? Well, when I take the square root of x squared, the squared and the square root are what cancel each other out. So I'm left with just x, or just whatever is under that square root symbol. Right, so again, the opposite of squaring something is taking the square root. So we get x equals 8. 8. We want units. 8 centimeters. Okay. No questions, we get that. All right, let's look at our last thing. Example 4, find the volume of this cylinder. So this is going right back to what we were doing yesterday. So we have volume equals pi r squared times height. Right. Well, we have our radius here and our height here. So we get pi. Our radius is 4. Squared. And then our height is 10. Again, we're just typing our 4 squared times 10 in our calculator. We get 4 squared is 16 times 10 is 160. I believe we get 160 pi meters cubed. Okay, so that's just going back to what we did yesterday. Simply solving for our volume. So this is just part A of the question. So if we look at part B, I'm now going to dilate the cylinder by a factor of 2, right? So now we're connecting this back to our similarity. Okay. Well, if I'm dilating it by a factor of 2, our radius was 4. My scale factor is 2. So my new radius is going to be 8 meters. And then our height was 10 meters. I'm going to scale it by a factor of 2. So our new height is 20 meters. So if I draw our new cylinder, sides, it has a radius of 8 meters and a height of 10 meters. Nope, 20 meters. Okay, so this is our new cylinder that's been doubled, right? Every dimension has been doubled. So now we're going to find the volume of the new cylinder. Volume equals pi r squared times height. Well, our radius from right above is 8. And our height is 20. So again, I'm going to type this part in my calculator, 8 squared times 20. And when I type that in my calculator, I get 1,280 pi meters cubed. So I doubled all my dimensions, right, my radius and my height, and I got a new volume. So now, kind of looking at this, do our volumes have the same scale factor that we used in part B, right? So we doubled all of our sides. Did our volume double as well? Okay. So let's check what our scale factor is. Right? So kind of going back to what we've been doing with our dilations. Remember, to find our scale factor, I can start with my start with my old shape, my original shape. And my original volume was 160 pi, right here. Times some scale factor, which we will find, is going to equal our new volume. Okay. And our new volume is 1,280 pi. So I'm going to solve for k by dividing by 160 pi. Those cancel, so I'm left with k equals, well, my pi's cancel, and all I have to do is 1,280 divided by 160. And when you do that, you get k equals 8. So, did I have the same scale factor here? No. Let's see. right? When I doubled the dimensions, and dimensions are just, right, length, width, height, radius, all those are like a dimension of your shape. So when we double the dimensions, the volume increased by a factor of 8. Right? So these things are not the same. When I double my dimensions, my volume increased by a factor of 8. So doubling your dimensions does not double your volume. Okay, it actually does way more than that, right?